practice A for section 5.3. We're going to use the information in the diagram to find the measure. So we have this angle, and this angle is bisected because we can tell these two little pieces, these two little angles are the same when this ray BD comes through. Notice how point D is measured to this ray 7 units away on a right angle. Now if you go from point D to this ray on the same right angle, what would that distance be? Well, we have an angle bisector theorem that tells you if these angles are the same, then these lengths are the same. So if that's 7, that's 7. Number 2, we're going to find the measure of angle DBA. Now, this is going to use the converse of the angle bisector theorem. So if you understood this, this is basically the same thing, only it's backwards. We don't know that this angle is bisected, but the theorem tells you if this distance and this distance are the same, meaning measured on a right angle, and they're equal, then these two angles are equal. So the measure of angle DBA is 20. We're going to find the value of x. We have an angle that's bisected. What are the values, or what are the lengths of these segments? Well, we don't know what they are, but we know they're the same. Set up an equation, solve for x. Converse, same thing. You have an angle. The distance from this point to each ray is the same, measured on a right angle, so these are the same. Set these equal, solve for x. Number 5, is the distance from D to A equal to the distance from D to C? You have an angle that's bisected. These distances are measured on a right angle. Are those equal? Yes. That's the angle bisector theorem. Now, this one is very close to being the same thing. You have an angle that's bisected, but these distances may not be the same because you don't know if these are right angles. Maybe this is a right angle here, and maybe this is an 89-degree angle, for example. If they're not measured on the same angle, then there's no guaranteeing that these are the same lengths. So I'm going to say I'm not sure because maybe they still are right angles, they're just not marked as right angles. If you knew they weren't right angles, then you could say they're definitely not equal. Next section, can you conclude that ray BD bisects angle ABC? This is the converse of your angle bisector theorem. These distances are measured on right angles and they're the same. So yes, those are the same. Does it bisect the angle? Yes. That's the converse of the angle bisector theorem. Number 8, these distances are the same, which is nice, but again, you don't know if they're measured on right angles. So is this bisected? You really can't conclude. Can you conclude? No, you can't. You can't conclude. You need right angles there. Maybe they are, maybe they aren't.